What up? Welcome back, man. Welcome back for a little bit of 5-minute practice. Power rule. Yeah, power rule practice. Here we go. Number 1. Oh, yeah. We're starting out kind of easy, huh? Stop. Never mind. It's not easy. It is easy, though. Ha! So, let's talk. Power rule, right? This is x to a power, x to a power. Whoa. That x to a power? I mean, technically speaking, I guess we could write it like this, right? I mean, x to the 0 is a 1, so negative 6 times 1 is x to the 0. We'll see how that affects what we're talking about. But let's do it. You remember the steps, right? Bring the exponent down, take the exponent down by 1. So let's do that. Yeah, for the first one, that's exactly what it would look like. Let's go ahead and clean that up now. But now let's move it all along. Next one. Yeah, exactly right. Bring that 1 exponent down in front and then take that 1 exponent down by 1. But remember what x to the 0 power is. A 1, exactly right. 1 times 1 times 1 is... Just remember, when you're taking a derivative on a power rule and you have a number, a coefficient, and just one of the variables, the derivative is that coefficient. Yeah, exactly right. When you think about it, isn't this a line with a slope of 5? What's the slope of that curve at any point? Bang, bang, 5, yes! All right, last part. X to the 0 power. We're not bringing this 0 down. Isn't that 0 times whatever? What is 0 times whatever? 0. The derivative of a constant is 0. Yeah, the derivative of just a number with no letters attached, 0. That's our derivative equation. Now, this will give us the slope of the curve at any point. So what if I wanted to find the slope of the tangent line, the slope of the curve, the instantaneous rate of change? What if I wanted to find that at an x value of 2? Where do you think I would plug that x value of 2 in? Exactly right. If I wanted to know the slope of the curve at 2, I'll plug a 2 into the derivative equation. It'll look like this. Just like that. Yeah. So what that means is at x equals 2, the curve has a slope of 21. No estimating, no approximating. That curve has a slope of 21. That curve is going up, positive slope, up very fast. It's going up 21 spaces for every one it goes across. It's going up pretty fast. And that's what the derivative tells us. Yeah. Let's try one more. Ooh, yeah, buddy. Now we're getting somewhere. All right, so here's my function. Here's my f of x, negative 4x squared minus 8x. Okay, good. Now the question is, at what value x is the derivative, f prime, equal to 0, right? So the derivative being equal to 0, we talked about that before as being a huge thing, right? Let me show you why. Let's say our graph looks something like this, right? Wouldn't it be really, really nice to know? I know a lot of people would really, really want to know about this point right here. Yeah, that maximum point right there. You know, for a number of different reasons. Let's say this graph has something to do with money and profits. Wouldn't you want to know what values would give you the most? Yeah. And the great thing about this point is, let's draw a tangent line. Yeah, remember that at maximums and at minimums, the tangent line is horizontal. What's the slope of that tangent line, a horizontal slope? 0. That's why they ask us about this all the time. Yes. You're going to be asked a lot where the derivative is equal to 0 because this. Yeah. That's where the derivative equals 0 at the maximum and the minimums. So let's do it. Let's do the problem. First off, let's find the derivative. Yeah, f prime. Let's do some power ruling. I'm going to bring the 2 down, multiply it by negative 4, and that is negative 8. Yeah. And then I take that exponent down by 1, which leaves x to the first power, or x. Exactly right. 1. Bringing this 1 down and multiply by negative 8 is negative 8. Exactly right. And when I take that exponent down by 1, it's x to the 0, which is 1, stays. Here's my derivative equation. But didn't they ask about that derivative being equal to 0? So can I just, yeah, and then solve. Let's solve this real quick. Add 8 to both sides and divide by -8. Yeah! So the derivative is equal to 0, or it's a maximum or a minimum at x equals -1. Look at that. Now, if I wanted to find the actual value of the maximum, wouldn't I just plug that -1 into the original? Exactly right. So the derivative is equal to 0 at a value x equals -1. And if I wanted to know the y value that goes along with that x value, plug it back in the original. Yeah, but question just asked about the value of x. Nice job, guys. This is going to kick up a lot. That's for the next video. I'll see you next time. Thanks for coming back, man. I hope this helped.